my channel. Today we are going to solve questions on indices. Number one, solution. The question says simplify 4 raised to the power half, that is 1 over 2, plus 125 raised to the power 1 over 3, all bracket raised to the power 2. So on a normal basis, when they give you this kind of question, if you are not conversant with laws of indices, you will begin to wonder how you will start and becomes a problem. But this is a very simple question to solve if you understand the laws. We have multiplication laws in indices, we have addition laws, we have power laws, and all the rest of them. So we're going to apply them carefully in this question now. First, let's solve them one after the other. Pick the numbers in the bracket, solve them one after the other. That's the easiest way to go. So you don't get confused and you don't muddle up things. So let's root out 4 raised to the power 2 to solve first. 4 raised to the power 2. What do you want to achieve? We want to understand the meaning of 4 raised to the power 2. 4 raised to the power 1 over 2. This is half. So there is a law in indices that says if x is raised to the power 1 over a, that law says it is equivalent. Whenever we say this means equivalent, it is equivalent to 8 root of what? X raised to the power 1, but most times 1 is negligible. So if you watch this, when we say laws, nobody is telling you to go and cram any law. Nobody is telling you to go and memorize any law necessarily. Just understand them, understand the applications. The essence of these laws is to make you get some questions solved very quickly and very fast. Now, this is 4 raised to the power half. From this, if you compare this now, you see that this particular number can be expressed in this nature. 1 raised to the power 2. So now x is the same thing as 4 here. This the same thing as this. Very simple. So we can represent it to be what? Root is now 2. Second root of what? 4 raised to the power 1. This thing is what we call law of indices. It's one of the laws. So what we are doing now is applying the laws. That is why it is very, very pertinent, very important to understand the laws of indices first, before start applying them in questions. So now, what is this? Already we know this is square root. So most times we don't write square here, unless you can only put the number here when it is beyond 2. When you now have something like 3, you can't keep root. So because once we leave it like this, everybody knows the square root. And once you leave it like this, everybody knows the square root of 4. And of course, square root of 4 is what? 2. So now, with this, we have done the job. We have done justice to this particular number, almost 80%. So this is it. So you can now say that this equation, this particular number can be written as square root of what? 4. Simple. Okay, now I don't want to ask you whether you can tell the square root of 4. Square root of 4, of course, implies what? 2. So whenever we write this means implies. This one means equivalent. This one is not this. This is equal to or equals. Where this is what? This one is equivalent. Where this one is implies. You don't use them. You don't model up things. Okay. Okay, now we have already done justice to this number. Let's pick 125 raised to the power 1 over 3 and do the same thing. 125 raised to the power 1 over 3. So from our law, basically, you can see this one is now cube root of this. It's not magic. Bring it out here. Remember our law that says 1 over a is the same thing as 8 root of what? X. Meaning that what we did before that 125 1/3 is equivalent to what? So now it's as simple as that. I don't know. I don't want to start asking questions, but you should know in this place, x is what we call the base. The base. X is base. S is called base. The base of this particular number. Where A, 1/A, is called index. Is either you call it index or you call it power, or you can call it exponent. So common sense will tell you now that indices, as you know, indices is just the plural form of index. So when we have two index, it becomes indices. So automatically this is laws of power, that is laws of indices. So now 4 here is base. So you can say this is base 4 raised to power half, that is a base with power of half and base of 125 to the power of 1/3. These terms are very, very important to understand because they are going to help us. So this is where we stopped. Now, what is the square root of 125? That's what we should do at this point. Can somebody help us? Okay. Okay. So now, since you know that this is equivalent to cube root of what? 1, 2, 5. How do we determine cube root of a number on a very low key? What can multiply? Because this power, well, in a law of indices, if you have that, let's say a number a raised to power x means a base raised to this power of x means that number, let a, what number can multiply itself till how many number of times? So a number called x. So if you have a here, what number can we multiply itself number of times to get to this place? Meaning if you have 8, okay, let's use a lower number. If you have 4 raised to power 2, this implies 2 is the power, that is the index. Meaning this is equivalent to 4 times 4 by 2 times. That's the number of times that number of times equivalent to the power. So if we want to have the square cube root of this number, meaning number that will multiply itself to a particular number of times until to get to 125. So how do we get it? In order not to trouble ourselves, we can easily use this method. Write 125. What are the factors? Let's use 5. 5 divided 125. 5 divided 12 is 2. You cannot divide 1, but you can divide 12. That is 10. It will now remain 2. So 5 divided 25 will give you 5. So 25 is still here. What another factor can go? 5. 5 divided 25 is 5. What? 5 is still here. What can go again? 5. 5 divided 5 is 1. So is there anything that can divide again? No. So this is 5 raised to power 3. Meaning that 125 is the same thing as 5 into 5 into 5. So the base is 125, but the base is 5, but the power is 3. So with this now, the cube root of 125 is 3. So this thing can be represented as what? As 5. As what? 5. This is just very simple, but we are starting. Gradually, we'll get there. So now we can represent this equation have been reduced to this form. So we can now rewrite our equation. Okay. So for now, rewrite this expression to be 2 plus this one is now 5. 5. This one has been solved and we got something like this 2. This one has also been solved and we got something like 5 raised to power 2. This is just very interesting. That's our final answer.